So this is lesson 3.2, graphing polynomial functions in college algebra. We're on page 270. And if you look at the bottom of the page, there are a couple things that are important. If p of x is a polynomial function of degree n. So let's just make a polynomial function of degree n. And then we'll just go from there. Minus 2x to the fourth plus 3x cubed, which is actually example 1, top of page 271. So it says if we have a polynomial function of degree n, and there's my degree right there, 4, at most n real zeros, and thus at most n x-intercepts. So that's what it's saying, is at most you're going to get 4 answers, which means it's going to cross the x-axis at most 4 places. Now we talked about this earlier. Sometimes it's less when we have a different multiplicity than 1. So if we have a multiplicity of 3, then we just get the same answer 3 times. So we still get, this number, 4 times. We still get 4 answers, and one of those answers may occur 3 times. So it only crosses it twice, because the one answer occurs 3 times. So anyway, and the second part says at most n minus 1 turning point. So if I have a graph that looks like that, and I have 2, 3, 4. Okay, so it crosses at 4 places. 1, 2, 3, 4. So it matches that. And it says at most n, which in this case is 4, minus 1 turning point. So 4 minus 1 is 3, which means when we do this, there's 1 turning point, there's 2 turning points, there's 3 turning points. So it changes direction. Whatever your highest exponent is, your leading exponent, minus 1. That'll tell you how many turning points you have on your graph. Okay, so let's go to example 1. We start getting into some really fun stuff here. So top of page 271. First, we use the leading term test to determine the end behavior of the graph, because they're asking us to graph this thing. So I'm going to set this graph off to the side here. So let's go ahead and solve this. One thing I know is I can take out a negative x cubed, and that leaves me with a 2x minus 3, which makes life a lot easier to work with. And we set that equal to 0 because we're interested in the x-intercepts. So we have negative x cubed equals 0, and we have 2x minus 3 equals 0, or x will then equal 3 halves. Alright, so notice what we have here. We have 3 answers that are 0, x cubed equals 0, and we have 1 answer that's 3 halves, and that matches our 4 answers here. 3 zeros, 1 3 halves. So we notice that our zeros have a multiplicity of 3, and our 3 halves has a multiplicity of 1. So if we go back to, I'm kind of getting ahead of myself here, so let me give my x-intercepts. My x-intercepts are at 0, 0, and at 3 halves, 0. So that's where I'm crossing the x-axis. So let me pull that up here. So I'm crossing at 0, 0, and I'm crossing at 1 1/2, 0. So I'm going to make this 1, 2, 3, just trying to make this a little bit bigger so you can see. And we cross at 3 halves, so right there. So those are my 2 places I cross. Now, what does this graph look like? Well, if you look at step 1, top of page 271, it says we use a leading term test to determine the end behavior of the graph. So if you go back to page 258, you'll see that because my exponent is even and my leading coefficient is a negative number, I am going to get the top right on page 258 graph. So it's going to look similar to, then who knows what goes on here, and then it comes down like that. So it's going to look like that when all is said and done. So it's going to cross at 2 points. So I could just kind of draw a little, who knows where all this other stuff is going to go. I don't know what happens up there, but I know it's going to look something like that. And I know because I have a negative here that it's going to go down. So, but with this 4 here, I know it's not just going to be a parabola, because a parabola is x squared. It's going to have something going on in here different than what I do for a parabola, but I'm not sure what at this point. So we're just going to kind of leave it alone. Actually, what it's going to do is it's going to come up and then kind of bounce around like that when all is said and done. So we'll get to that in a minute. So at this point, we only have our shape. And like I say, our shape is going to be like that, similar, but again, we don't know what happens in here. And I know that it's going to cross the x-axis at 0 and at 3/2. And I also know that my 0 has a multiplicity of 3, and my 3/2 has a multiplicity of 1. Okay, so what happens is, if you look here, it will divide my graph into 3 separate areas. And this is some of the new stuff that's coming up, is getting used to being able to do this. So 3 separate areas that we're looking at. Okay, so what I'm interested in doing here is I'm interested in finding out what happens in this area, in this area, and in this area, in all 3 of my intervals is what we're going to call them. So at -0 or negative infinity up to 0, I want to find out what's going on there. I want to find out what's going on between 0 and 3/2, and I also want to find out what's going on. Let's see if I can get rid of some of this. I want to see what's going on between 3/2 and positive infinity. Okay, so those are my 3 areas. Negative infinity to 0, 0 to 3/2, and 3/2 to positive infinity. Okay, so what I'm going to do is I'm just going to stick a number from this interval here and see what happens, see what my y value is. Stick a number from here, see what my y value is, or put a number here and see what my y value is. So the book just has, we'll put in a -1 for my x value, because that's going to be right there in that interval to the left of 0, 0. And I'm going to put a 1 for this interval right here. And then I'll put a 2 in for this interval. You pick any number you want. You just pick a number that's going to be easy to work with. Alright, so when I put a -1, the one I picked here, into my original problem here, it's going to kick out a -5. When I put in a 1 into this problem, it's going to kick out a 1. When I put in a 2 into this problem, it's going to kick out a -8. Okay, so when I plug in a value for x, it's going to give me a p of x of -5, 1, and 8. Alright, all I'm interested here is the sign here. A negative, a positive, and a negative. So I'm going to put that down for the next one as far as the sign of my p of x. A negative, a positive, and a negative. Okay, so what that's telling me is, things are going to move around here for a minute, but bear with me. Let's just look at the graph here. what that's telling me is that when I put in a negative number, or when I put in a number over here, my y value is going to be below my x-axis. So it's going to come, my graph is going to come from down here, and I've already determined it's going to go through here and through here. So it's going to come from down here instead of from up here, because when I put in a number over here in this interval, it gives me a negative y value. So it's going to be a number down here. So it's going to have to come up. This next part says, let's move this back, when I put in a number from this interval between 0 and 3/2, in this case I put in 1, it's going to give me a positive answer. So what that's telling me is it's going to give me an answer that is going to be above the x-axis. And when I'm over in this interval, I put in a 2, it's going to give me a negative, so it's going to be back down here. So what that's telling me as far as my graph is concerned is that I'm going to get a graph that's going to come from down here, come up into the positive area, do something up here I don't know, and then come back down, so that in my third interval, in this interval over here, it's going to go back and be negative again. And that's what we said in the very first one, is, or when I started, is you looked on page 258 to get an idea of what this graph was going to look like. So it was going to come up, do something funky, and then come back down. Okay, so that's what I found out. And I also know that it's going to make that many 4 minus 1 turns. So notice what we have down here when I look at my graph. If it comes up like this and down like this, it only makes 1 turn. It says up here that it has to make 3 turns, 4 minus 1. I'm only seeing 1 turn, so we're going to have to figure out what happens up in this area here in order for it to make 3 turns. So let's keep going here. Okay, so I think I have it cleaned up a little bit. So what we have then is we can start graphing some of this, because when we plugged in some of our test points here in these different intervals, we have a negative 1, 5, a 1, 1, ignore that minus sign right there, and a 2, negative 8. So let's go ahead and graph those. So I can put in negative 1, 1, 2, 3, 4, 5, so it's going to be way down low. So let's just kind of move that, and it's going to be somewhere down here. And I've got a 1, 1. It's going to be up here somewhere. And I have a 2, negative 8. That's going to be way down here somewhere below the graph. So I have a couple points there. And then I can put some additional points in there. One of the key things is I want to know what my y-intercept is. And we've already determined that it's 0, 0, just because of where one of the crossing points are that we found earlier. When we were solving for x, we found out that we got negative x cubed equals 3. So we know that it crosses, or negative x cubed equals 0. So we know it crosses the origin here. And we just start plugging in some different numbers to find out what happens. And as you plug in some different numbers, you find out that your graph ends up looking like this. And then it comes down like that. Let's try it again. It goes up, hits that, comes up, comes down like that. Okay, so when you add some more points in there, and again, you're going to want to add points that are between these two, because you know something weird is going to happen. So you're going to have to put enough points in here to see what kind of weirdness goes on, and that's right here. See how it makes that weird little jump there. So what happens is, look, we should have 3 turns. 1, 2, 3. Okay, so it's the 4 minus 1. So the book says that it only has one turning point. It looks at this as being the turning point right here. So the rule is, if you look back on page 270, it can have at most n minus 1 turning points. I still like to look at it as 3. It just kind of keeps things straight, that something weird happens at 3 different places. But I guess I should say officially it has one turning point right here where it stops from going up and turns and comes down. But here it just kind of does something weird, and then here it does something weird. So I always count that as my 3 turning points, but I guess it should be just one turning point. It only has 2 intercepts, even though there's a 4, because that 0 occurred 3 times, and then there is our other one here, which is our 4th. Multiplicities are odd, okay, because we had an x cubed equals 0, and then we had our, what was it, 2x minus 3 equals 0. That occurred once. So because we have an odd multiplicity, the graph crosses the x-axis at 0 and 3/2. And the end behavior of the graph is what we described in step 1. Remember, we had at the very beginning, we said it was going to do something here and then weird and then come down. So it was going to look like that. So we have that information there. So anyway, there's our graph of that, given this interval stuff. This interval stuff we're going to be doing a lot of, so just get used to messing with that. Okay, let's do another one. Top of page 273. So our leading term here is 2x cubed, and because we have a degree of 3, which is odd, and a positive leading term, we know that our graph is going to look something like squiggle, 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 and then something like that. So we know it's going to look something like that, but we don't know exactly what's going on here. Alright, so we're finding the zeros first. So this is the step 2 that we're doing, finding the zeros of the function. So we're going to set this equal to 0 and get rid of our f of x here. So we'll just make it equal to 0 because we're looking at where it's going to cross the x-axis. So let's see, what are we going to do with this? We're going to break this into 2 groups so that we can factor out an x squared and then be left with 2x plus 1. And then we'll group these 2 together. And we get, then we can factor out a -4, or factor out a 4 and be given 2x plus 1. And that equals 0. And then that and that are the same. So we get x squared minus 4 times 2x plus 1 equals 0. So we get x plus 2, x minus 2, 2x plus 1 equals 0. So we get our 3 answers. So my zeros are -2, 2, and -1/2. So those are my zeros. Each one has a multiplicity of 1. So because the multiplicity is odd, I know it's going to cross the x-axis. I have 4 intervals in my graph because I have all the numbers on this side of -2. I've got the numbers between here, that's the second interval, the numbers between here, that's the third interval, and the numbers this way is my 4th interval. So really you just look at this and say, oh, there's 3 answers, 4 intervals here. So my intervals are -∞, -2, -2 to 2, all the numbers between there, 2 to -1/2, and all the numbers there, and then all the, whoops, I'm sorry, I've got to rearrange this in order because I've got -2, 2, and -1/2, so those are all right, but they're not in line in order, so I'm going to have to do -2, -1/2, and then +2. Okay, so they didn't change, it's just my intervals look a little weird if I don't. So negative infinity to negative 2. Then I go from negative 2 to negative 1/2. That's one thing you got to keep straight, and I wasn't paying any attention to what I was doing here. Negative 1/2 to 2, and then 2 to positive infinity. Okay, so there's my 4 intervals. So then I just take an x value, doesn't matter what number I pick as long as it's on one of the intervals. So the book chooses negative 3 for there, chooses negative 1 for this interval, 1 for this interval, and 3 for this interval. And then we're going to pick an f of x, or we're going to find our f of x by plugging negative 3 back into that original equation, and we get negative 25. We get a 3. We get a negative 9. And we get a 35. So all we did was took our numbers that we picked here, put them back up here into our original equation, and it spit out a 35. Okay, so really all I'm concerned about here again is our sign. So I've got a negative sign, a positive sign, a negative sign, and a positive sign. So see, one of the things that's good to notice is, see how my signs alternated? It won't always happen that way, but that means it started in the negative below the x-axis, went above the x-axis, went back down below the x-axis, and went back up. So it kind of went up, down, up, down. So each one of these tells you that you're changing direction. So from here to here we're changing direction, from here to here we're changing direction, and from here to here we're changing direction. Okay? So that's what it looks like as far as some information there to graph this. So let's go ahead and move this up so we can graph. Because right there we have 4 points that we can start graphing here. So let's go ahead and do that with what we've got. Okay, so we're at negative 3, negative 25, so we're going to get a point, and use red here, we're going to get a point way down here. We're getting a point at negative 1, 3. So we're getting a point up here somewhere. Well, actually, and then we're getting a point at 1, negative 9. It's a point here. And we're getting a point at 3, 35. So we're getting a point somewhere up here. And what it says is we're starting down here in the negative direction, going up, and then we're going to be coming back down, and then we're going to be going up again. Okay, but I don't really know what's going on all throughout this area here. I don't know how high up it goes, I don't know how low it goes, and I don't know if any weird things happen in here. So we're going to go ahead and look at this. So because we're going to put some additional points in here, we find out that we cross the y-axis at negative 4-ish. So, oops. So let me see if we can make it cross the y-axis somewhere like negative 4. So it's going to cross down here somewhere. We're going to find out by completing or putting some more numbers in there that I end up going up not much higher than this, about 3.5 before it switches direction, and switches direction there. So it kind of looks like that when I put some more points in there. And if you look on 274 left hand side, they added some more points. We know that the degree is 3 and that the graph can have at most 3 x-intercepts, and in this case that's how many we have, and at most 2 turning points, and that's what we have. So it has 3 x-intercepts, 2 turning points. Each 0 has a multiplicity of 1. Thus the graph crosses the x-axis at negative 2, negative 1/2, and 2. Because remember, if the multiplicity is even, it's going to be tangent at those places. But since the multiplicity is 1, it's going to actually cross. It has the end behavior as described in step 1 from page, gosh, what page was that? 258, where you know what's going to do in the end behavior. And the graph just appears to be correct as far as what we've got there. Okay, so there we go. Just kind of a little estimate of what that graph is going to look like. So this is example 3 on page 274. Now some of these graphs are going to look like that, or polynomials are going to look like that. You're going to be like, oh man, I can't do that. Well, fortunately, they factored it for you. We'll learn how to factor these later, but right now I'm just going to go ahead and give you the answer. Notice the multiplicity on the x minus 2 is 2, which means it's even. My leading term is 4, and it's positive. So I know my graph is going to look like that. Okay, I know it may cross the x-axis at 4 places, but could be less. And I also know that I'm going to have at most 3 turning points. So my zeros are easy to find here. For this one it's -1. For this one it's 2, which actually occurs twice. That's what our multiplicity here is, and 4. So I know it's going to cross the x-axis at -1, 0, at 2, 0, and at 4, 0, which gives me 4 intervals again. So my zeros divide the x-axis into 4 intervals, and those 4 intervals are -infinity, -1, -1 to 2, and then 2 to 4, and then 4 to positive infinity. So those are my 4 intervals, and I'm interested in what's going on in those 4 intervals. So in order to do that, I'm going to plug some numbers in for x, and it has to be a number again, somewhere in there, somewhere between there, between there, and between there. And sometimes the intervals that you're given are so small that you're kind of stuck with decimals or fractions. And one of the things they did in this particular one is they put some test values in there that were decimals. And I'm not sure why they did that, but in any case they did it. And I'm not going to do that. I'm just going to say, you're going to put in a negative number here for x, and you're going to put in a number between -1 and 2 here. Here they put in a 1. Over here in this one, they put in, what, -1 1/4. So they're assuming you have a calculator and you can put those in. In 2, 4, they put in 3. And 4 to infinity, they put in 4.25. And then it spit out 13.9. When we put 1 in, we got a -6. When we put a 3 in, we got a -4. And 4 1/4, we got a number around 6.6. Okay, so the sign is what we're interested in. And here we got a plus sign, and over here we got a plus sign, but here we got a negative and a negative. So notice that kind of follows what our graph is looking like. We're up above the x-axis here, or we're going above the x-axis here. We started from above the x-axis here, but notice we've got a negative and a negative, so it's going to do a couple negative kind of stuff. It's not going to come above the x-axis until here and here. So it's going to do something like, well, let's see if I can kind of give you an idea. If I've got my graph like this, it's going to come below, and it may move around and do some different stuff here, but see, it's not going to come above until this point right here. So it's going to stay down in that negative area for both of these intervals, and that's okay. So let's get rid of this and see what actually happens here. So we can go ahead and let's move this back down like that, we can go ahead and draw our graph. And we can put these test points that we had. So we know that we have a point there, a point there, a point there, and a point there. And we also know that our x-intercepts are at -1, 0, and 2, 0, and 4, 0. But notice, remember our multiplicity up here. We had a multiplicity of 2 on our x minus 2, so at this point we know we're not going to cross the x-axis. We're just going to be tangent to it. And then we'll go back down and cross here where our multiplicity is odd, and right here where our multiplicity is odd. But here, where our multiplicity was even, we had x minus 2 squared, it's not going to cross. It's just going to be tangent. So let's see other points that I have. -1, 0.25, 13.9, so it's going to be up here somewhere. Let's just put a point there. And it's going to go down, down, down to 1, -6, so it's going to be down here somewhere. And then we've got a 3, -4, so it's going to be here somewhere. And then we've got a 4.25, 6.6, it's going to be here somewhere. So our graph is going to do something. Not exactly sure how far down it's going to go. I didn't plug enough numbers. I know it's going to be tangent here, then it's going to come back down, and then it's going to go up like that. Might be good to find the y-intercept here. So if you were to plug 0 in for your x values, obviously you're going to get -16 for your y-intercept. So that means it's going to be a little bit different than that graph, because where it crosses our y-axis is going to be quite a ways down here. So it's going to go way down here and then up and then curve and then up and go like that. Okay, which matches what the graph looks like. We said it was going to start here and come down and then go up, and we didn't know what it was going to do in here, and that's what we were finding out is what it did right there. So that's it for example number 3. Okay, this last section here on 276, the intermediate value theory, shouldn't take too much time. And what the intermediate value theorem says is that if I have a y value here that's positive and a y value here that's negative, or vice versa, as long as one of them's positive and one of them's negative, that means that somewhere along this line we have to cross the x-axis into negative territory. So if my P of A is positive and my P of C is negative, or I'm sorry, P of B is negative, I'm going to have to cross the x-axis somewhere. If it was the opposite and my P of A was negative and my P of B is positive, somewhere in here I'm going to have to cross the x-axis to get up there. Okay, that's basically what they're saying there, is that will be the truth of the matter as far as your x or your y values. Alright, so now they're giving us a couple of examples using that intermediate value theory. Determine whether the function has a real zero between A and B, meaning does the graph cross the x-axis between A and B. And so the first one, somewhere between -4 and -2. So if we have the graph and one of our numbers is -4 and one of our numbers is -2, does the graph of this equation right here cross somewhere between there? Does it cross the x-axis either this way or this way? So what we do here is we just plug in the -4 in here and see what our answer is, and we plug the -2 in there to see what our answer is. So when we plug -4 in, we get -24. So when my x is -4 and my y is -24, when I plug -2 in, I get an 8. So notice what we've got here. One y value is negative, the other y value is positive. So because of that theorem, my y values have opposite signs when I plug my x values in, so therefore I cross the the x-axis somewhere between -2 and 4, because when I put in -2, I got 8, and when I plugged in -4, I got -24. So somewhere, we don't know where, somewhere between these 2 points, this graph has to go across the x-axis to get up here. So it does cross the x-axis. So therefore, our graph confirms the fact that we end up crossing somewhere between -2 and -4. If you put in, so for part B, if you put in -1 and you put in 3, well, let's see what we get here. If I can erase all this. Okay, so I put in -1 and it spits out a 6. So far that works. Plug in a 3 and it spits out an 18. Both of these are positive. So between -1 and 3 it does not cross the x-axis. So there's no zeros between -1 and 3. If we put in, for C, it said we put in a -1/2, and when we do that it will spit out a positive 7/48. When I put in a positive 1/2, it spits out a -5/48. So therefore I know it crosses the x-axis because of that. And D, when we plug in a 1 and a 2, they're both negative, so it doesn't cross the x-axis. So anyway, that is it for 3.2.